Kotlin vs Java, which programming language should you learn in 2020? It has been several years since Kotlin came out, and it has been doing well. Since it was created specifically to replace Java, Kotlin has naturally been compared with Java in many respects. To help you decide which of the two languages you should pick up, I will compare some of the main features of each language so you can choose the one you want to learn. To start it all, let's do some basic syntax comparison. Many of you who are reading this might already have some knowledge about Java and/or Kotlin, but I will give out a basic example below so we can compare them directly. The feel of the code isn't that different aside from some small syntax changes in the methods and classes. But the real difference here is that Kotlin supports type inference where the variable type does not need to be declared. Also, we don't need semicolons anymore. We can also note that Kotlin does not strictly enforce OOP like Java where everything must be contained inside a class. Take a look at funAge and funMain in the example where it is not contained inside any class. Kotlin also typically has fewer lines of codes, whereas Java adheres more to a traditional approach of making everything verbose. One advantage of Kotlin over Java is Kotlin's flexibility. It can choose to do everything in the traditional OOP approach, or it can go a different way. If we are talking about Java and Kotlin, of course we have to talk about the famous Lambda expression. Kotlin has native Lambda support, and always has. While Lambda was first introduced in Java 8, max strings a beta a length less than b length in Java. The parentheses are more lenient if only one parameter exists. There is no need for parenthesis. But in Kotlin, brackets are always required. Overall, however, there are not many differences aside from syntax. In my opinion, Lambda functions won't be used much aside from using them as callback methods. Even though Lambda functions have so many more uses, readability issues make it less desirable. They'll make your code shorter, but figuring out the code later will be much more difficult. It's just a matter of preference. But I think it's helpful that Kotlin enforces the mandatory brackets to help with readability. In an object-oriented language, null type values have always been an issue. This issue comes in the form of a null pointer exception (NPE) when you're trying to use the contents of a null value. As NPEs have always been an issue, both Java and Kotlin have their own way of handling null objects. As I will show below, print b, for as long as I can remember, Java has been using traditional null checking, which is prone to human error. Then Java 8 came out with optional classes which allow for more robust null checking, especially from the API server side. Kotlin, on the other hand, provides null safety variables where the variable must be nullable if the value can be null. I haven't really used optional class yet, but the mechanism and purpose seems pretty similar to Kotlin's null safety. Both help you identify which variable can be null and help you make sure the correct check is implemented. Sometimes in code there might be just too many variables lying around and too many to check. But adding checking everywhere makes our code base ugly. And nobody likes that, right? In my opinion, though, using Java's optional feels a bit messy because of the amount of code that needs to be added for the checks. Meanwhile, in Kotlin, you can just add a small amount of code to do null checking for you. Some people might also refer to this as the entity class. Below you can see how both classes are used as model classes in each language. var student equals student John Doe. 21 in Java. Properties are declared as private, following the practice of encapsulation. When accessing these properties, Java uses getters and setters, along with the isEqual or toString methods when needed. On the Kotlin side, data classes are introduced for the special purpose of model classes. Data classes allow properties to be directly accessed. They also provide several inbuilt utility methods such as equals, toString, and copy. For me, data classes are one of the best things Kotlin offers. They aim to reduce the amount of the boilerplate code you need for regular model classes. And they do a really good job of that. Sometimes your code might need a variable needs to be accessed everywhere in your code base. This is what global variables are used for. Kotlin and Java each have their own ways of handling this. Some class global number. Some of you might already be familiar with the static keyword here since it's also used in some other language like C++. It's initialized at the start of a program's execution, and is used by Java to provide global variables since it is not contained as an object. This means it can be accessed anywhere without initializing the class as an object. Kotlin is using quite a different approach here. It removes the static keyword and replaces it with a companion object which is pretty similar to a singleton. It lets you implement fancy features such as extensions and interfacing. The lack of the static keyword in Kotlin was actually quite surprising for me. You could argue that using the static keyword might not be a good practice because of its nature and because it's difficult to test. And sure, the Kotlin companion object can easily replace it. Even then, using static for global variable should be simple enough. If we are careful with it and don't make it a habit of making every single thing global, we should be good. The companion object might also give us some flexibility with interfacing and such. But how often will we ever be interfacing singleton classes? Nowadays, concurrency is a hot topic. Sometimes the ability of a programming language to run several jobs concurrently might help you decide if that will be your language of choice. Java mostly uses threads to support concurrency. In Java, making a thread requires you to make a class that extends to the inbuilt Java thread class. The rest of its usage should be pretty straightforward. While threads are also available in Kotlin, you should instead use its coroutines. Coroutines are basically lightweight threads that excel in short non-blocking tasks. Concurrency has always been a hard concept to grasp, and also to test. Threading has been used for a long time and some people might already been comfortable with that. Coroutines have become more popular lately with languages like Kotlin and Go. Go similarly has coroutines. The concept differs slightly from traditional threads. Coroutines are sequential while threads can work in parallel. Trying out coroutines, though, should be pretty easy since Kotlin does a very good job explaining them in their docs. And one bonus for Kotlin over Java is the amount of boilerplate code that can be removed in Kotlin. But I can't help but mention it, because extension functions are a very useful feature that was introduced in Kotlin. They allow a class to have new functionality without extending it into the class or using any of the fancy design patterns. It even lets you to add functionality to Kotlin variable classes. You can practically say goodbye to those lib methods that need you to pass everything inside your parameters. Last but not least, let's talk about something non-technical. First, let's take a look at this survey showing top commonly used programming languages in 2020. We can see that Java is one of the most commonly used languages. And while Kotlin is still rising a lot in popularity, the Java community still remains several times larger than Kotlin and it will probably not change anytime soon. So what does that matter then? Actually it does matter a lot. With the amount of people in the Java community, it's much easier to find references and get help when you need it. Both on the internet and in the real world. Many companies are also still using Java as the base and it might not change anytime soon even with Kotlin's interoperability with Java. And usually, doing a migration just doesn't serve any business purpose unless the company has really important reasons for it. Syntax, the patterns don't differ that much aside from slight syntax differences. But Kotlin is more flexible in several aspects. Lambda expressions, the syntax is almost the same. But Kotlin uses curly brackets to help readability. Null handling, Java uses a class to help with null handling while Kotlin uses inbuilt null safety variables. Model classes, Java uses classes with private variables and setter, getter while Kotlin supports it with data classes. Extension functions, a new feature introduced by Kotlin to easily give functionality into classes without extending it. Community, Java still reigns supreme in the community aspect which makes it easier to learn and get help. There are many more features we could compare between Java and Kotlin. But what I've discussed here are, in my opinion, some of the most important. I think Kotlin is well worth picking up at the moment. From the development side it helps you remove long boilerplate code and keep everything clean and short. If you are already a Java programmer, learning Kotlin shouldn't be too hard and it's okay to take your time at it. Thanks for reading. I hope that this article will help you decide which programming language you should pick, Java or Kotlin. And for anything that I'm missing, feel free to leave feedback for me, as it will be very much appreciated. Learn to code for free. FreeCodeCamp's open source curriculum has helped more than 40,000 people get jobs as text source, freecodecamp.org.